challenge. I want you to think. I want you to see if you can come up with two fractions that when multiplied together make an answer of 1. Only stipulation is your fractions themselves cannot be equal to 1. So for instance, you can't do 2 over 2 times 4 over 4, making 8 over 8, which is 1. I want you to see if you can come up with two fractions that when multiplied together, the product is 1. Think about it. Well, just throw it out there. We'll test it. Charlie, first crack. All right, let's see if he's right. What's 2 times 4, everybody? What's 8 times 8, everybody? That is definitely not equal to 1. Try again. Alex. Can't be. Okay, 2 over 4. What's 2 times 2, everybody? What's 4 times 4? That is not equal to 1. Fail. Aiden. Okay, let's try it. 2 over 4 times. What's 2 times 2? What's, oops, sorry, my bad. 2 times 2 is 4 the last time I checked. 4 times 1. We have a winner. Okay, now I want to take this a step further though. This fraction, 2/4, what does it reduce to? God, just scared me to death. All right, Aunt. I'm just going to rewrite what Alex had said.
Can I get this? Is it reciprocal fraction?
Say it for the national audience. What are these fractions called?
Reciprocal fractions.
These are reciprocal fractions. This is by definition what a reciprocal fraction is. It's two fractions that when multiplied together make a product of 1. Okay? So any fraction times its reciprocal is going to equal 1. Give me a fraction. Any fraction. Doesn't even have to be over 1.
5 over 10? No, what?
I could do 5 over 10, but I can reduce 5 over 10. Give me a fraction that's already in simplest form.
Oh, 1 half.
Don't make one of them 1.
3/4.
3/4, thank you. Watch what happens. Watch what happens. 3 over 4 times, what's the reciprocal for 3/4? 4 over 3 equals what over what? Which is equal to what? Which is equal to what? Which is equal to what? Anybody? Okay? That's what reciprocal fractions is. It's two fractions when multiplied together make a product of 1. Okay. So some of you started to discover this when we were doing lessons 1 through 4. You started to figure out what Stephen Prass has known all along, is that we can take any fraction expression or any division problem, and we can use reciprocal fractions to make division even easier. Before we get to that, let's just revisit this problem from lesson 4. It's the same exact problem from lesson 4. We had 3/4 being divided by 6. Who remembers how we did this using a tape diagram? We did it 2 ways. Smiley. Okay, let's start off with that. 6 boxes. And then what, Smiley?
And then we broke each box into 4.
Well, what's got to go into this? What fraction? Right, so it's 3/4 has to go into 6 boxes evenly, and then we couldn't do that. We had to do something with the 3/4. Do you remember?
Yes.
Do you remember? No need to shade in this case because our 6 holes are our 6 holes. We could shade it, but then we're right back to where we are with just 6 boxes being shaded, so we might as well leave them unshaded. Anthony, do you remember? No, we didn't. And we didn't flip it. we had to make an equivalent fraction, remember?
Oh, yeah.
Because you can't put 3/4. You had to try to figure out how much of this fraction goes into each box, and that's kind of hard to do. So give me an equivalent fraction for 3/4. Max.
8/24.
I could go 8/24, but there's a smaller one that will work for us. Steven.
6/8.
6/8 will work because look, now if you have 6/8, how much is the value of each box? It's probably good that we're revisiting this anyway because you forgot. Think about it. What plus what plus what plus what plus what plus what is 6/8?
Oh.
See, that you got to think that's what division is. Z. Right, remember we did this in a warm-up, 1/8 plus 1/8 plus 1/8, or 1/8 times 6 is the same as 3/4. So each box is worth 1/8. Therefore, 3/4 divided by 6 is equal to 1/8. That was using a fraction bar or a tape diagram. Took even longer doing a numbered line because you had to change these fractions into a like denominator first. So let's do that. 3/4, and what is 6 as a improper fraction? Not a reciprocal fraction. What is it as an improper fraction?
6/1.
Right. Okay, so we have 3/4, 6/1. This is going to get in the way. I don't want to do that either. Yeah, where's my green pen? Is it on my desk?
Yeah. I saw it.
It's okay. Stay there. Oh, it's not working.
Oh.
Just start over. Sometimes we make the easy more difficult.
There it is.
Plug that up for me. Thank you. All right, look at your 1 and your 4. What is your... I'm a little crammed here, so wherever you have space that makes sense is fine. What should my lowest common denominator be? E squared. 4 will work. So 3/4 could stay 3/4. And then what does 6/1 become as an equivalent fraction with a denominator of 4? Krista. Okay. See how much time this is taking us already? Then our think statement, because you got to remember, it's small number being divided by a large number. How many? What should that be? I want you to think about it because this has been a common mistake so far in the tests that I've marked for that very last question on part 2, yesterday's test. A lot of you reversed this. You can run into some trouble. How many what in what? Ryan Russo, you got first crack. Obviously, if you get it right, we're good. If you get it wrong, it's the other way around.
How many 6
Yeah, now just take your 6 and change it to the improper fraction that we created. He's got it. He said, how many 6 in 3/4? All I'm asking you to do now is what did we make 6 as an improper fraction?
24/4.
Oh, that's correct. Okay, remember, this is my go, this is my leap. And then I got to start to number this in 24ths, which takes time. But I'm going to do it. Follow up with me and do this on your own too. Just enough lines. My go-to is 3/4, right? Where do I have to leap to? It's only one leap, and guess what? It's a partial leap, isn't it? Where does that partial leap need to go to? Somebody I haven't heard from. Aiden. It's partial leap, so we're going to do a dotted line. Now we know that our answer's got to be less than 1. So what fraction is that partial leap? Remember, that's how many steps to get to the go-to out of all the possible steps. Liam? 3/24. Which reduces to what? 1/8, which, doesn't that make sense? That's what we got when we did tape diagram, 1/8. Time consuming, right? What you started to realize, maybe you forgot, I don't know, is that when you got your 3/24 and you look back at the original, we kept the numerator 3, we took the whole number 6, multiplied it by the denominator and got 3/24. Everybody see that? Okay. In essence, what you did is something called keep, change, flip. Here's how it works. Okay, here's how it works. Here's that. Is there room on the bottom? I think there is. Squeeze this in there. Here is that original division problem, right? What is the 6 as an improper fraction?
24.
Not as an equivalent fraction, just as an improper fraction.
Oh, 6/1.
Right, 6/1. What we did, everybody repeat after me. Keep. When we say keep, it means we keep 3/4, 3/4. Everybody say change. When we say change, we're changing division to multiplication. Everybody say flip.
Flip.
Flip means you're taking the reciprocal of 6/1, which is 1/6. And you get 3/24, which reduces to 1/8, and it takes a lot less time. Okay, so now don't be mad. Don't be mad at me because you see, I've heard it say, well, Mr. Leslie, why didn't you just teach us 2 weeks ago? The idea behind Common Core, and I kind of got to tell you that I kind of believe in it, is that you start to realize on your own that keep, change, flip will work for division without me just telling you it right off the bat. You kind of discover it on your own, and that's that deeper understanding part of the new standards, which I kind of like. It's just going to make it a lot more meaningful for you if you understand why this works. And it will work for any fraction, as we're going to prove in this next example. So if you go to the next page, skip this because I talked through this, but it's here in writing if you need to refer to it. And we're going to model this one just one more time, just to make sure that it works for any fraction. Because now, we now have a fraction being divided by a fraction. Let's just see if it works with anything. Okay. Unfortunately, with 3/4 divided by 2/5, it's a little bit more difficult to show it through a tape diagram. So we're going to go to the number line. And it's good to practice this anyway, because you guys are still having trouble with this. You were having trouble with this on the test. I have my 3/4 being divided by 2/5. And the first thing I want you to do is come up with a common denominator for both. The lowest, if we could. For 4 and 5, what's the lowest? Okay, so this over 20 and this over 20. Four times what makes 20? You could just say it out loud. It's okay.
5.
So 3 times 5 is 15. 5 times what makes 20?
4.
And 4 times 2 is? Okay, here comes the thing statement. Look back at the problem. Order matters. What into what? How many what in what? Kaylee Cams. Very good. Okay, now I got to make my number line. 0, and we're counting in increments or interval of 20ths. Yeah.
6 is wrong. How many 15, 20 20ths or an 8/20th.
No, look at it.
Isn't it 3/4?
It's how much of the second fraction in the first fraction.
No, you wrote how many 8/20ths. Oh.
Right, how many 8/20ths in 15/20ths? We're good. This one gives me one more than I need, but that's okay. What's my go-to? Practice it. What's my go-to? Smiley? 15/20ths. Remember, my second fraction in my think statement, always my go-to. So therefore, I'm leaping by, you can just say it out loud, 8s. First leap is a complete leap. I have at least one. Second leap, I have at least 2. Oh, I made a mistake, didn't I? Yeah, I made a mistake. My go-to is 15/20ths, which is going to make this leap a partial leap. My bad. Sorry. However, my leap's got to go to 16. So now we have 1. And what's the fractional leap? Still, we need practice with this too. Jack.
1/7/8.
Right, because look, you have 1, 2, 3, 4, 5, 6, 7 steps to get to the go-to out of 8 possible steps in the partial leap. Now, from beginning to end, that took me about 4 or 5 minutes to do that, right? Let's do keep, change, flip, and keep track of the time and see if we can cut back on time. I'm not going to even charge my time limit for rewriting the problem, but I'm going to do that now. What was it? I don't even know. 3/4, 2/5. All right, so ready? Starting my time right. Perfect. Right now at 9:45. Keep. Change. Flip. 5 times 3. 4 times 2. Improper fraction, need to change it back into a mixed number. 8 goes into 15. How many times? So you did it on the sprint practice last night. 1 with 7 left over. 1 and 7/8. Stop my clock. 29 seconds. Pretty cool. Therefore, now it will work with any fraction. Keep, change, flip from here on out.
Oh yeah.
Couple of things that I want you to watch out for, though. Okay, go to the next page because I'll let you guys do this on your own, but I want to make sure that you don't make the mistakes that I see every year. This is kind of like your reminders page. What's our page number on this? 8? 5. Okay, number 1. Only the second fraction gets flipped in keep, change, flip. I see some kids that want to do the first one, and then I see some kids that want to do both. If you flip the first and not the second, or flip both, you're going to get the answer wrong, so you got to be careful. Number 2 is a big one. I saw this in period 2. All mixed numbers have to be changed to improper fractions first. Do that in one step, then do your keep, change, flip. Don't try to do mixed numbers to improper fractions and keep, change, flip in the same step. You'll run into issues.
Can you do it though? Like, is there a way?
I'll give you a for instance though. Look, skip this for now because you can do this later. I'll give you a new page. Say you've got 3 1/9 divided by 2 3/8. I see kids that want to do this. They want to change this into 28/9. And then they want to do keep, change, flip, and change this into a mixed number or to an improper fraction all in one step. So they do 16, 19, and they get mixed up. And then they're going to want to multiply through, and right now, no good. This still has to be division. All I did in that step was change my mixed numbers to improper fractions. Then I do keep, change, flip. Keep, change, and then flip and do it. Don't try to combine it into one step. always simplify the answer. Sometimes after you do your keep change flip and you multiply through, you could still reduce your fractions. Change all improper fractions back into mixed numbers. An improper fraction by definition means the numerator is bigger than the denominator. If you get a final answer, guys, that is 8/19, is that an improper fraction? No, it's not. The top number has to be larger than the bottom number, and if the top number is smaller, you don't need to change it into a mixed number. You may need to reduce it, but you don't change it into a mixed number. I'll see some kids will take this and they're going to want to say, oh, 8 goes into 19 2 times with 3 left over, and want to make this 2 3/19. It's not an improper fraction. It's a regular fraction. It stays as is. So you want to watch out for that as well. And then just make sure your answer makes sense. If the second fraction is bigger, or let's say it's bigger than the first fraction, then your answer is going to be greater than 1. If your first fraction's bigger, sorry, I had that reversed. If your first fraction is smaller, that makes your second one bigger. That means your answer is going to be less than 1. But if your first fraction's bigger than your second fraction, then your answer is always greater than 1. So just be careful.